Hi everyone, I got a request through my YouTube channel to do a comparison between the class methods isAssignableFrom and isInstance. So here is the video based on that request. So I've done up a UML diagram here, got an interface movable, which is a super interface of drivable. Then I've got a vehicle which does not implement either of those interfaces. We've got a car, a bus, and a train. They all extend from vehicle, and car, bus, and train are all drivable because they implement the drivable interface. That's what this code here is in diagrammatic form. So an overview of the differences that we will see are that isAssignableFrom takes in a class as its parameter, whereas isInstance works with objects. That leads us to point 2, in that isAssignableFrom can take an interface type. And point 3 is when they're dealing with nulls. isInstance, when you pass in a null there, you'll get back false, whereas if you pass it into isAssignableFrom, you'll get a null pointer exception. So let's just refresh by starting to look at the instance of. So I'm creating a vehicle and I'm creating a car. The instance of, is C an instance of vehicle? Yes, because a car is a subtype of vehicle. Is C an instance of drivable? Yes, because the car class implements the drivable interface. Is V an instance of car? No, it's the other way around. And the same for V instance of drivable? No, there is no direct relationship between vehicle and drivable. The third one there of V instance of car, that vehicle could be a bus, could be a train, so that's why that comes back with false. Now the isInstance is very closely related to the instance of. It takes in an object. Again, I'm going to create the same two objects. Vehicle V is assigned new vehicle and car C is assigned new car. Is C an instance of car? That's the way I read that, going from right to left. Is C an instance of car? Absolutely, that's exactly what it is. And V is an instance of the vehicle class. Yes, it is. That's true as well. Is C an instance of vehicle? Well, C is of type car. Car extends vehicle. Therefore, that is true. C is an instance of vehicle. But it's not the other way around. Vehicle is not necessarily an instance of car. The third one, all cars are vehicles via inheritance, but not all vehicles are cars. Some could be buses, some could be trains, etc. What about if I put in an interface there? Is C an instance of drivable? Yes, the car class implements drivable. That returns true. Is V an instance of drivable? No, that's false. Vehicle does not implement drivable. And if I pass in null, the isInstance comes back with false. isAssignableFrom, you can see the signature there. It takes in a class. Now, I just want a quick point here on vehicle V is assigned new car. That's fine. All cars are vehicles. But if I wanted to get this to compile, I need to put in the cast, where I say car C is assigned new vehicle. Compiler won't allow that. So you have to put in the cast to downcast from your vehicle to your car. Will you get a class cast exception at runtime? Yes, because you've got a car C reference referring to a vehicle. Car cannot refer up the tree to a vehicle object, because a car could have extra methods that are not in the vehicle class. So this is the same idea what isAssignableFrom is going to try and come back and tell us. So here, car.class, is that assignable into a vehicle.class? Yes, a car is a vehicle. Again, I'm reading these right to left. Vehicle into car, no, it's the other way around. What about if it's an interface? Car, is that assignable into a drivable? Yes, it is. Vehicle, Is that assignable into drivable? No, there's no relationship between vehicle and drivable. Now here's one of the differences. I'm putting in an interface class here. Can't do that with the isInstance method here. It's looking for an object reference. But here I can pass in an interface class. What am I saying here is, can the drivable be assigned into a car? No, it can't. Can a drivable be assigned into a movable? Yes, because a drivable is a sub-interface of movable, and that's why I put in the movable interface in there. So the car.class is a drivable, so you can do that. And a drivable is a movable, so you can do that as well. You can assign it into it. And that's essentially what it's telling you. If what's in here is a subtype or a sub-interface of what's over here, then it'll be okay. And if it's the same type, obviously, that's fine as well. And this is the one that'll give you the null pointer exception. If you pass in null, you'll get a null pointer exception. And then I just have one or two miscellaneous ones here at the end. I'll just make it bigger. The vehicle.class is assignable from c.getClass. That is equivalent to vehicle.class isInstance. So that will come back with true, regardless of whether it's true or false. In this case, it's true because C, which is of type car, is an instance of vehicle because car extends vehicle. And therefore, the c.get class, which will be car, is assignable into a vehicle. This one is true as well, but it's false for both sides. It'll be false is equivalent to false. So the vehicle, is that an instance of car? No, its car is an instance of vehicle. Then you go v.getClass to get vehicle.class. Is that assignable into a car? No, because then you'll be pointing up the tree. So just to summarize, the isAssignableFrom will take in a class, which means we can pass in an interface type. The isInstance is always expecting an object, therefore you can't pass in an interface because you can't instantiate an interface. If you pass in null, the isInstance behaves differently to the isAssignableFrom. The isInstance will give you back false, whereas the isAssignableFrom will give you back a null pointer exception. So I hope you liked that video. If you did, please click like. And if you haven't already subscribed, please consider doing so because there's lots more content coming. Thanks very much.